All right, number 4. You're standing on a scale. Let's see. So you're standing on a scale in an elevator that's going down. You got through the problems, right? Yeah. Okay, so you're standing on a scale, elevator that's going down. So here is my elevator, here's my scale, here's me. Okay, there is a force of gravity down. There is a normal force up. We're not in free fall because we're in an elevator. So there's a normal force working against gravity, not drag, not air resistance in this case. Okay, so next thing I need to do, like always, is draw the net force or the acceleration. So I labeled my forces, and I actually think, like, you guys have been doing a good job with these diagrams. Like, I've been pretty pleased with how they're going. And the better you do with the diagram, the easier the rest of the problem is, because you just have to look at the picture and put things together. So in this case, we've got an acceleration. It's going down, speeding up. So to go down, speed up, my acceleration needs to be down. Here I am, I'm going to write A equals 1.4. Down is the direction I'm traveling, so I'm going to make down positive and up negative. You're welcome, like some of you have done this backwards from me, and that's fine. Okay, there's my diagram. Picture, forces, acceleration / net force, directions. Okay? Now, the next step is always find the net force. That is always the next step. Find the net force. So, how do I find it? Well, I either find it by adding the forces together, or I find it by doing mass times acceleration. In this case, I don't know the normal force or the force of gravity, although, to be fair, I can find that pretty easy. But I do know the acceleration, and I do know the mass. Okay? So, I'm going to do F net equals ma. Mass is 61. A is 1.4. Gives me a net force, 85.4. Okay? Now that I've got the net force, there's always one more step to do. Net force is never the end step. So if you find the net force and you're like, sweet, I'm done, then nope, you're not. Okay? I'm never going to say, what's the net force? I'm never going to end the problem there. Okay? Where I'm going to end the problem is, okay, now that I found the net force, find what I'm missing. In this case, I wanted to know what the normal force would be. So that's your other equation now. F net equals the sum of the forces. Okay, so what are my forces I'm summing together? Normal and gravity. Those are the only ones. So it's going to look like this. F net equals positive force, gravity, plus your negative force, normal. And if you did minus the normal, it would work out fine in the end. But if you don't know it, I just always add. I just always add everything. I add everything, and then I add negative for the direction, depending on what they're going in. Okay?
Question.
Yeah?
What's that next to the F on the top?
This?
The little squiggly line is something.
It's the Greek letter sigma, which means sum. It just means add. Yeah. You know sigma.
Where's that?
Yep. Okay. So now we put in the numbers that we know. Fnet is 85.4. Now, I was not given the force of gravity, but good news, you can always find it. Because Fg is always equal to mg. Always and forever. The mass is 61. G is 9.8. Okay, so 597.8, that becomes Fg, plus normal, which is what I'm solving for. So all I have to do is subtract the 597.8 to the other side. When I do that, I get a normal force to be, normal force to be negative 512.4. Yeah. Okay, let me come around and see how you guys are doing. Are there any questions on that one? Anything that you need me to go over again or explain?